Okay, just wait. Are you able to see the screen here?
Yes, sir.
Okay, am I audible now?
Yes, sir.
Okay, समझ रहा है ना? तो
सर आवाज नहीं आ रही।
बताओ भाई, आप सुनाई दे रहा है?
हाँ सर,
इस बार लाइटिंग तो नहीं आ रहा है ना?
अभी नहीं आ रहा है।
चलो
फिर से लैग हो रहा है सर।
के पहले जो मैं डिस्कस किया था वो तो सही से सुनाई दिया। हेलो,
हाँ सर, सेमीकंडक्टर
सेमीकंडक्टर
वगैरह
पहले
सुनाई
उसका
दिया।
की।
ओके सो
डोपिंग वगैरह पूरा
हाँ
सुनाई दिया था।
ओके सो uh, um, what it is means normally we will take a pure semiconductor, right? So and that pure semiconductor will be called as an instructive semiconductor, and then some impurity will be added in that, like a trivalent or pentavalent materials will be added. If a trivalent is added to an pure semiconductor, then it is called as a p-type semiconductor, right? And if a pentavalent is added to a semiconductor, then it is called as an n-type semiconductor. Okay, and the p and n has been called because for the trivalent you are going to have three valency electrons. That means the outermost orbit is going to have three electrons there. So you are having one empty space, and that will be acting as your hole. Okay, and in electronics the hole will be considered as a positive, so it is a p-type. And similarly, if the pentavalent is been added, so the pentavalent is going to have five electrons, and one will be excess, and it will be act as a donor. So that is the reason why it is called n-type. Okay, so यहाँ तो सुनाई देगा सर इससे?
हाँ सर।
So what I want to say here is, so on the screen you can see a diagram here, right? So that is the diagram is an strain gauge, okay? And as in the previous one, normally we can see that the strain gauges are designed by using the resistors here, okay? So but this strain gauge has been designed by using the semiconductors, and I want to explain you the how this strain gauge has been designed here, okay? So how it is designed here is, so one Okay, so you can see here, so this black one, this complete black one here. So this black one is an n-type pan. Okay, that means you are going to take an n-type semiconductor pan, and on that you are going to diffuse the p-type material. So you can see on the here, you can see here in this plate S1, S2, Q1, Q2, or R1, R2, T1, T2. All these are semiconductors, and the p-type semiconductors are diffused there. Okay, and here it is also going to do the same thing. Okay, whenever you are going to apply some force on the strain gauge, it is going to convert that into an electric voltage. Okay, so but you are already know that, or one thing you have to remember here is, so whenever you are going to use the semiconductors, there you have to consider the temperature there, right? Because whenever you are going to have the temperature, so whenever the temperature increases here for a semiconductor, okay, as I said, the resistors are going to have positive temperature coefficient. That means whenever the temperature is going to increase, so the resistance is going to increase there. Okay, but whenever we're going to come into the semiconductors, okay, so in the semiconductors, what's happening here is whenever the temperature increases, so there the resistance of the semiconductor material is going to decrease. Okay, so this will affect the majority of our transaction process. Okay, so to eliminate that, as I have said to you that we are going to have four arms, and each and every arm is going to have one resisting material there, right? But here you can see that completely n-type material, right? On the n-type plate we have diffused 4 p-type, not 4, we have diffused the 8 p-type materials, right? I have not diffused 4, I have diffused 8. Okay, and in the below screen you can see here, as you can see here, here, okay, um, T1, T2, S1, S2, R1, R2, and Q1, Q2. That means each arm of your Bridgestone bridge. In your bridge, you are having four arms, and each arm is having two materials connected in series, in cascade, or you can call it as a cascade. Okay. So the reason why we had connected the two resistors cascade in a one arm is to reduce the temperature. Do that mean to reduce the temperature effect, or you can call it as a for temperature compensation there. Okay, so and the remaining everything will be same here. So this is also going to convert the force into a voltage, changing resistance. Okay, sorry, the force into changing resistance, because the semiconductors are going to have some resistance there, and they are going to do the same thing. The only thing that you have to remember in this type of strain gauge is whenever you are going to apply some force on that, it is going to convert the main thing you have to remember here is you are taking a p n type plane, and on the entire plane you are diffusing the p-type material, and you are not diffusing 4. Instead of 4 you are diffusing 8, because the semiconductors are more affected by the temperature. Okay, to compensate the temperature effect we are diffusing 2 per arm. Okay, you can see on the bottom figure T1, T2, Q1, Q2, S1, S2, R1, R2. So we have diffused 2 per arm to reduce the compensation effect here. Okay, तो यहाँ तक समझ में आया? आवाज तो कटा नहीं है ना?
हाँ सर है सब।
Okay, so this is the strain gauge construction. Okay, so the PPT has been ended. Wait, let me open the 1 minute. 1 minute. Just wait for 1 minute. Okay, so I want to show you this image here. Okay, are you able to see on the screen? Encoder using a binary counting system. Are you able to see on the screen?
Yes, sir.
Yes sir.
Okay, so this is an encoder. Okay, so as I had shown to you that LVDT, I had shown you LVDT, or before that I had explained you the potentiometer, I had explained you different types of transducers which will convert the displacement into electrical voltage there. Sorry, my screen has been stopped. Okay, 1 minute, 1 minute. Okay, 1 minute. 1 minute, 1 minute. Okay, so I had explained you the LVDT and I had explained you the potentiometer, which is resistance, and along that I had explained you how inductor and capacitor is also converting the displacement into electrical voltage, right? But each and every one which I had explained you previously, okay, just forgot the strain gauge, okay. So whatever the remaining parts, that means the LVDT, the potentiometer, and whatever the other things I had explained you, okay. So जो कि ऑन लगता है माइक वो लोग माइक ऑफ करने ना यार डिस्टरबेंस आ रहा है थोड़ा okay so whatever I explained you all those are converting the displacement into electrical voltage but the only problem there is they are not converting into an digital signal right so they are just giving an electrical voltage and that may be an analog or digital but they are not giving you exact digital signal like 1010 okay they are giving AC and DC voltage output, but they are not able to give the digital signal. But as you know that in most of the instrumentation applications, digital signal plays an important role. Okay, so you can see on the screen this one. So this one you can see on the screen. So this is the encoder. Okay, angle what is this encoder is going to do this is going to convert your angular displacement okay so whatever angular displacement you are going to have so this is going to convert this angular displacement into digital signal okay so how it is going to convert this okay you are going to take a copper plate so this complete circular part is a copper plate here and you are going to etch it that means etching means you are going to apply some photographic element on this copper plate but you are not going to apply the element completely on the copper plate how you are going to apply this like you can see on the outer ring you are having different concentrated circles on this okay so you can see at the outer just remember the outer one okay so this outer one okay I'm zooming it so you can see this outer one here okay so this outer one is going to have 12 sections okay black white black white like that if you observe the outermost thing so outermost thing is having 32 segments sorry the outermost thing going to have 32 segments okay 16 segments are etched with the photographic material and 16 segments are not etched with the photographic material and similarly it will get decreased okay the first one will be 32 and then 16 and then 8 and then 4 and then 2 and the last one the inside one is going to have only complete one black ring that is one okay so how it is going to convert here is you are going to place this encoder on a shaft let us consider we are having a shaft and we want to measure the linear displacement of the shaft okay so we are going to place this encoder on a shaft and whenever the shaft moves okay whenever the shaft moves and you can see here we have places some um, counters digital counters here okay so what these digital counters do so whenever the shaft moves okay whenever the shaft moves and stops at a particular position so this counter will measure how many lines are aligned that means how many sections as I said that the outermost is going to have 32 sections in the another one will be 16 and our inner one will be 8 and inside one will be 4 and then 2 and then 1 okay so like my shaft has been rotated and came here okay so there at that position it will count how many HC sections. That means how many physiological sections and how many non sections will it will measure, and depending upon that, it will give a digital count there. Okay, so it will act like that. Okay, like you can see all these are in single line. So in this single line, it is having no black. Everything will be white here. So it will give a count of 0. So it will rotate more. So let us consider it has came in this part. So if it came in this part, then here you can see that it is having 4 black segments and 2 white segments, then it will give the count depending upon that. So how this digital encoder is going to work? It is going to convert your displacement into a digital signal. This 2110, that means it is going to give a count here, and depending upon the count, like if you get the 32, it will convert into BCD system, or if you're going to get 16, it will be converted into BCD system. Okay, so this is one of the encoder. Okay, so this is not that much important. I just explained you to so that you can know that there are some digital encoders which will convert your displacement into an um, a digital signal okay so there is nothing difficult in this here we have divided the complete plate into concentric circles okay the outermost circle is going to have 32 sections that means 16 black segments and 16 white segments and it's inside one is going to have 16 and then 4 and then 3 and then you can see the inside one this is going to have only one segment that is completely black Okay, so what is happening whenever you are going to place this encoder on a particular shaft for which you want to measure the displacement. So the shaft will rotate. Whenever the shaft will rotate, so it will stop at one particular position and want to measure that displacement. So at that displacement, you will measure how many black and white segments are there. And depending upon the number of black and white segments, you are going to get the digital count out there. Okay, so in this way, this is going to convert the displacement into a digital signal. Okay, so only the black and white segments are going to do there. Okay, समझ में आया?
Yes, sir.
So this is one of the encoders. Just it is going to convert the displacement into other signal, but this time the signal will be a digital signal. Okay, and it convert the digital signal depending upon the black and white segments present there. Okay, so ज़्यादा confuse मत होइए. ओके, एक बार आप टेक्स्ट बुक में फिर से रिवाइज करेंगे तो आपको समझ में आ जाएगा. ठीक है, अगर मैं पीपीटी आपसे शेयर करूंगा इसका, so then I will write something so that you can understood this. ओके, तो यहाँ तक समझ में आया.